And welcome to another exciting medical terminology video. Today we're going to be looking at the special senses, and as I have nearly said in almost every single video up until this point, this is just going to be the broad overviews, and we're going to essentially look at a variety of special senses. Your book ends up actually splitting these into a couple of different chapters. There's some of it that's at the end of the nervous system chapter. There's also a special chapter for the eyes and for the ears. I'm going to focus more on the eyes and the ears, and then we're going to go from there. Some of the fun things about the special senses is that they have very similar sounding types of terms. So things having to do with the ear is aural, as opposed to speaking, which is oral or having to do with the mouth. O versus AU. So these are some of these different types of things that you're going to have to keep in mind. Otherwise, it's the exact same type of business that we've been doing throughout the whole entire time. I essentially already covered this, but there's a ton of terms that generally follow the normal type of naming scheme in this type of area. Prefix, combining term, and then suffix. And that quiz might be a little bit of a hefty pull, but you can still do it. And once again, as always, if you have any types of questions in any way, shapes, or form, please come and see me and go ahead and ask either in person or by email. When we're looking at the ear, I actually thought it was kind of interesting that Microsoft PowerPoint actually pulled this spiral, the snail shell, as part of the ear. The major organ of the ear is called the organ of Corti, or the cochlea, and that has a spiral type of shape to it. And I'll show you a picture in a little bit, but it's very similar to a snail shell. So here is that organ of Corti, or the cochlea, and that is essentially part of the inner ear. So we have the outer ear with the auricle, the external auditory canal, so that's your ear canal. You have your tympanic membrane, your eardrum, the malleus, incus, and stapes. It is malleus, incus, and stapes. That's not stapes, it's stapes. And the malleus, incus, and stapes have other names, including the hammer, the anvil, and the stirrup. They are called that because the hammer looks vaguely like a hammer, the incus or the malleus looks like a hammer, the incus kind of looks like an anvil, and the stapes definitely looks like a stirrup. The base of the stapes is on the oval window. The oval window then vibrates and provides vibrations in the cochlea, which makes information go to the cochlear nerve. So oftentimes, if you have some sort of hearing processing device, a cochlear implant, that cochlear implant hooks up to the cochlear nerve and stimulates it in a similar way that the cochlea would itself. The acoustic or auditory nerve is one of the nerves that ends up going into this, and sometimes you'll see the vestibulocochlear nerve. So that is has to do with the vestibule, which deals with rotation and movement of your head. So that is in this general region here, and the cochlea. If you have ear tubes, those generally end up making it so that water can go from one side of the ear and out down through your throat. So generally that happens if you have a lot of problems with your ear growing up, and then they either get removed or otherwise, and it heals up. Other different types of things that you may refer to. So the auricle is your external, that's like what most people think of as your ear. Sometimes it's also called a pinna or pinnae. That's more often in other different types of creatures, but sometimes you'll see it in humans. The auditory canal is also the external acoustic meatus. That's also where cerumen shows up, which is earwax. Earwax is actually good for you. It helps trap stuff so that it doesn't go in and attack anything. The middle ear contains the ossicles. Ossicles are just little bones, malleus, incus, and stapes. The eustachian tube that helps equalize air pressure and other different types of things along those lines. That's why sometimes if you're on an airplane or in a place where somehow or another you have plugged ears, it helps to swallow because that helps bring change the air in your eustachian tubes. Cochlea um, is the organ of Corti, and that contains hair cells. Hair cells vibrate to open and close potassium gated channels to make it so that you can actually hear things. The vestibule is where the utricle and saccule are, and they hang out and have movement based things. They actually have these awkward bits that kind of look like jello with chunks of rocks in them. Those rocks are called otoliths, lith meaning rock, oto meaning ear. So otoliths, ear rocks, that help you with equilibrium and balance. So figuring out what is facing up versus facing down. And then you have your semicircular canals, which go in 3 different rotations and allow for rotational sensing. And so sound ends up getting pulled in by the pinna and the auricle. So the same way that if you put your hands like this, you can suddenly hear more things. Really, the purpose of the ears is to funnel that sound into your auditory canal. This then causes vibrations because sound is just movement of airwaves, but it'll cause vibrations in your tympanic membrane, which will then vibrate the malleus, the incus, and stapes, and that helps amplify the vibration to get it to your inner ear, to the cochlea. The cochlea starts moving different types of things around, which then makes it so that the fluids move, which then move the hair cells in the organ of Corti, which then get transmitted to the nerve fibers, which then go to the cerebral cortex for processing. And that is how sound works in a nutshell. Once again, if you have any types of questions about this, please go ahead and ask.